So my dream in these early days was to become an engineer. My grandfather had some background in chemistry, and an uncle was titled engineer, and that stuck in my mind that maybe this is something for me. I did better in science and math than I did in English, so it was a natural progression. So my time during wrestling, I became third in the state of New Jersey and was recruited by the New York Maritime wrestling coach to wrestle for him and also pursue an engineering degree. That was fruitful, and I ended up, as a result, working in the nuclear industry, performing design work for nuclear plants early on in the 1970s, and proceeded with a career of 40-some years in that industry. It required understanding the inner workings of the power plant and the systems involved that allow the safe operation of the nuclear station. During my time at work, I managed to get a patent, which was a real big accomplishment for an engineer. This patent allowed me to figure out a way to measure control rods in a nuclear station to see if they had deformed in any way. So a non-destructive test that used eddy current, which is not the likely place to go to do this, but through manipulating the configuration, I could measure the profilometry of that control rod and determine if it could be used again. Up until that time, they would just throw the rods away after 7 years of usage. So this ended up being, I think, produced quite a bit of money for the company I worked for. I ended up just getting a plaque and a $50 gift certificate to go out to dinner. So after 40 years of this, working at Millstone Station most of the time, I retired, and during that retirement, my sons all of a sudden had an interest in science and the universe and gravity and quantum physics, and so they said that they would like to discuss it, or we ended up discussing it, so I decided to study it so I could give them the proper information. It ended up to be quite a study that encompassed at least 5 or 6 years of my life, and then all of a sudden, with all this information, I started deeply thinking about how the universe works and how also gravity works. The universe was my first topic of discussion, and I noticed that the dark energy that was proposed actually added so many questions to the mix of questions that already existed in the observations they've made about the universe, that I started thinking maybe there's an alternate way to explain all the observations. The thinking that went into this goes back to my days in doing my artwork and being able to visualize the systems involved and trying to put in the laws that relate, which is really only one law. Gravity is the law that affects everything at a distance and is the major input. So considering dark energy, it has been searched for and not found in 25 years of intensive searching. This means to me that dark energy could be part of the problem. And assuming dark energy causes the expansion of the universe is possibly one alternative. Back in the day when, in 1998, when they determined through supernova observations that not only was the universe expanding, but it was accelerating. And that's when dark energy was invented to explain it. And what had happened is they used Einstein's cosmological constant and brought it back. Einstein said himself that was his biggest blunder, and he put that in his equation to balance out and make static the universe, which was the prevalent thinking at the time. So this was something totally added and had no scientific background, except that that's what they thought, and they made the equations to support that view. So upon looking at this with all the missing information that supports dark energy, I started thinking of an alternative way that the universe might work. And the most obvious is that the missing mass causing this expansion of the universe is outside the universe itself. Dark energy puts it inside the observable universe. So what that means is there's something outside that affects the whole universe and has the energy to pull it. And once this mass is located outside, gravity can do the work that they're postulating dark energy would. Dark energy being inside the universe means that it has to be a repulsive force. And so that adds so many questions because never have we been able to produce a repulsive force. And it has not been observed in the universe. So it really becomes into questions. So what we have to figure out is, okay, if the mass is outside the universe, then what configuration could it be to affect the whole observable universe and make it expand as a system? And the logical explanation is that a shell sphere of black holes is outside the universe. It has great momentum and also has a critical mass to make up the total universe now, which consists of the shell sphere of black holes, dark matter, and the observable universe. So looking at this from a system approach, which I have strong background in, working with systems and how they function together to support an outcome, this becomes an alternate solution. And out of that, when you analyze the movement of that part of the system, the shell sphere of black holes, to the observable universe, all the expansion modes can be explained, and every observation that's been made by Webb can be explained. It leads to a closed, cyclic, sustainable universe that works on gravity alone. So that you want to review the paper and you'll get all the details, and we'll talk about that later. So in my gravity paper, which came along after my universe paper. In fact, I almost didn't do it because I figured everybody's been looking at this and really found nothing to go forward, after Einstein. So what you have to do in this case is just look at what attributes that we know of that gravity has. The things like Newton's equation, which I could understand. I started there. And also the fact that Einstein presented that gravity is the same as acceleration. So how does that happen? And then thinking about how gravity for a planet like the Earth is always there and always being generated, and you see no loss of energy or mass as a result of it. And it exists forever, and that's hard to explain in science, but that is indeed the truth, and I haven't seen that brought up as an attribute in any of the books I've read. So when looking at this and seeing that Newton's equation proposed that gravity is proportional to the total mass product of two objects divided by the distance squared apart, and then seeing that Cavendish came along and experimentally found that the cosmological constant was 6.68 times 10 to the minus 11th power, it points towards that gravity is really related to a smaller directly related to a smaller portion of the mass. And so what could that parameter be? That's the question that has to be asked, that seems not to have been asked for over 200 years. And if you pursue that line of reasoning, you very quickly end up with a little twist in it that gravity is related to the missing electrons, the missing mass, in orbs that are formed by accretion. So when accretion happens, you have collisions and energies, and the number of collisions count the energy of those collisions that form each orb. So it turns out that gravity is likely related to the missing mass, and it can be equated to Newton's equation, and you can find out just how many electrons are missing, and also the number of charges that are missing by with my art and engineering experience, this led to me having the capabilities to visualize systems and be able to generate new ideas. The phrase comes to mind, looking outside the box. This is exactly relates to how the universe works, and where you look for the missing mass, you're looking outside the universe to find it, and it produces a system that indeed does work to explain everything about the universe. So in summarizing, the universe has an alternative model that can explain everything, and you can see all the details in my paper, which we'll show the link to. And also with gravity, it's essentially a missed opportunity back from Newton's time to find the direct relationship to gravity. And that is the summary of where we're headed. As an example of how my art affected me, I have these two sculptures that I did at different times, and one represents my subconscious thoughts during the time I was about to get married, and that was the same time I was starting my engineering career in nuclear power. This piece represents the wedding entanglements that I was about to enter in getting married, and I did this totally from the subconscious. I didn't think about what I wanted to carve. I just carved it, and this is what turned out, and later on I called it wedding entanglements. And with this, I also wrote the lit part of this, and this was done long after the carving was done, when I started thinking about that aspect of art, where you can add literature on the backs of paintings, or in this case they're attached to the bottom of these, and it gives a moment in time that when this piece of work was done, and kind of connects it to the time frame. And so what I visualize is that future art shows might pick up this as an art movement and called art litism, and you can look that up and you'll see my website, just art, ARTLITISM, and you'll get my website and see the art and how I visualized this movement might proceed. So 40 years after that, I decided, well, I'll do another carving. I like this. And in this one, this is called Life's Entanglements. And indeed, it does have some litism associated. Here is one of my paintings from 2018. And I wanted to have you look at this, and then I'll read the art litism that's on the back. This painting is called My Mothy Friend, Fly With Me. Come fly with me, my mothy friend, my love. Tonight we will see the stars and go to the moon. It is the biggest, so must be the most powerful light. I have a new plan. We will go to the highest tree. After many flights, we will arrive at its top. I'm sure with just a few flaps of our wings, we will be in the purest light, the promised light. It will be the one true light that will be our salvation. When we arrive, we will fly in it with no harm, for this light will have no flame. We will be the first to be greeted by God. Follow me, and we shall remain in the light forever. And as I said, this was done in 2018. Thank you. My name is Robertrgaunt. I started out in Pennsylvania and New Jersey, and I got involved with art really early in my high school days, doing oil paintings and some carvings like you see here of sculptures. I spent my early days in Pennsylvania and New Jersey, and had a good sporting career in high school, and football and wrestling, and continued wrestling in college at a fairly high level on the East Coast. That provided me a method of being successful in my life, and really helped to build confidence as a youngster. The art part of it came through going to museums and seeing what's out there and determining that maybe I could paint. Just having that thought gets you to be able to do something that maybe you have fear of. And of course, anything you have fear of, you should pursue that because it holds you back in a lot of ways. With art, I started copying things early on just to get some confidence. Things like Van Gogh made an important impression. And I copied some of his paintings, Starry Night and the cafe scene. And I built some confidence up in doing it, and I pursued it for the rest of my life. Sometimes I wouldn't paint for 10 years, sometimes. But then I would always get back to it after a little hiatus, depending on what was going on in life. Okay, we're going to discuss the gravitational mechanics, a new model of gravity. Where we start out is with Newton's equation for gravity that ends up having gravity related to the total mass of objects. When the experiment was finally done to determine the proportionality constant to that, Cavendish did this in the 1800s and produced a gravitational constant of 6.67 times 10 to the minus 11th power. That means that anybody evaluating that would say that, well, we can say that gravity is related to a small amount of the total mass. And we might ask that a question of what that parameter might be to get at the direct relationship to gravity. And that would make the gravitational constant 1 with its units. The units stay with it to keep the equation balanced. And that's one leg that we use in this new gravitational theory. Another one is Einstein's equivalence to gravity through acceleration, which was a new concept in Einstein's time, and it's saying that gravity and acceleration are one and the same thing. The other part that we need to look at is the molecule and how the molecule creates the four forces. And with those four forces, we have the strong nuclear force, which keeps the nucleus together. We have the weak nuclear force that works with radiation to allow the molecule to achieve balance by losing extra neutrons. And then we have the electromagnetic force, which is set up with the nucleus and the electrons that go around the nucleus. So now we have gravity left. So how does gravity relate to the molecule? There has to be a connection in my mind. The other thing that comes to mind, and this is something that I came up with later, is that gravity is a force that is here on Earth, and every other orb in the universe has gravity. And from what we can see, there's no depletion of energy or mass that produces the gravitational field. And there's no energy required to go into it to produce the gravitational field. So I haven't seen that as an attribute to gravity. However, it is a very strong one that gravity seems to be a force that is a free lunch. You get a force for nothing. And this doesn't go along with much of conservation of energy and mass. So from these four basically attributes of gravity, we can begin to really look at the details of gravity. So to recap, and we'll go through each one. With Newton's equation, gravity is proportional to the mass of one object times the mass of the other object divided by the distance apart squared. Pretty nice, simple equation. And then, as I said, that Cavendish figured out the gravitational constant, and it's a very small number. So we asked the question, well, what could the parameter be that gravity could really be related to directly? And we get rid of the gravitational constant, it goes to 1, and we have the simple solution to gravity. With acceleration, we find that if we visualize the molecule during acceleration, we see that the electrons will go in the opposite direction to the acceleration. So what will happen is it imbalances the molecule, and that imbalance is what I would say causes gravity in all these cases. If you lose electrons, that imbalances the molecule, that causes gravity. If you accelerate something that moves the electrons, it deforms the molecule, and again causes gravity. Now, the other aspect to acceleration is that when you decelerate, what happens? Well, all those electrons that have been pushed to one side due to the forces of the acceleration end up springing back, and that's why when you decelerate, you will fly forward. And in reality, what that represents, and nobody said this yet, is a repulsive force. So now we have acceleration being able to cause both gravitation and also repulsion, a hint towards what's to come. The next thing is the molecules and how that works into it. So we can say from looking at acceleration that anything we do to form the molecule potentially could cause gravity or repulsion. So with asking that question of Newton, at Newton's time, I mean, this question could have been asked anywhere along the way. It's almost 300 years since Newton came out with this. The other thing that happens is that everybody that's looking at this, all the astrophysicists, they want you to direct your any inquiries to Einstein's gravity, which is the present theory that overrides Newton. And what that tends to do is to not look at the basics, and you end up with a situation where Einstein is so hard to understand that 90% of the people will walk away from it instead of trying to understand it. So when we consider Newton's equation that proposes that gravity is proportional to the total weight of an object, we can now consider that the loss of electrons is the direct relationship, the loss of the electron mass, and this happens to every orb in the universe when accretion happens that forms every orb. Accretion is collisions with other objects in space to form larger objects. And when that happens, there's different energies involved, and there's different masses colliding involved. And that knocks off electrons on molecules and embeds those from the very interior as the orb is forming to the outside layer. You have molecules that are missing electrons. And that does represent a very small portion of the mass, and thus is a parameter to consider in this. And it turns out it's one of the only ones. The things that you can identify is that you have collisions, and there's energies to those collisions, and those things, the number of collisions and the energy, is also proportional to the total mass. And I haven't seen that mentioned in any of the books I've read. So to change Newton's equation now, we can get an idea of the mass of the Earth by setting up Newton's equation with the total mass and using the proportionality constant. And if we do the mass of the Earth and the mass of the Sun times the proportionality constant, we can make that equivalent to the number of electrons that are missing in the Earth, the number of electrons that are missing in the Sun because of accretion. And now we have an equation that relates the total mass now to the small missing electron mass. And we can solve it using Newton's idea to determine how many electrons are missing in both the Sun and the Earth that cause the gravity. When we do that calculation, it turns out that we get the Earth's missing electrons as 1.71 times 10 to the 34th electrons, and the Sun's electrons are 5.13 times 10 to the 40th missing electrons. What we can predict then is that with missing electrons, we affect the charge of the object, and we can predict what the charge would be if indeed the Earth is missing this many electrons that I just told you about, or the ones for the Sun, the missing electrons for the Sun. So we can predict now the charge that we might expect for that orb to have. And for the Earth, we end up with a charge of 2.74 times 10 to the 15th coulombs. And for the Sun, we end up with a charge of 8.22 times 10 to the 21st coulombs. This is a predicted value, and this would be a means of substantiating this theory. One of the problems is that, as we know with the Earth, trying to measure the charge, what's happened is electrons have collected all around the Earth because of the Earth is positively charged, and we have a lot of trouble measuring that. It means drilling down and getting the highest charge reading you can get of the Earth and eliminating the electrons that are on the outside to get that value. Not an easy measurement. However, it is predicted that we should get that kind of a charge if this theory is right. The other thing that happens is that we can figure out just how many, the mass of the electrons that is needed, say, to counteract the Earth's gravity. And that number is 1.558 times 10 to the fourth kilograms of electrons, which is a small number. Now, all of a sudden, we have a means that we can control gravity by adjusting essentially a small number of part of the mass in the Earth or in any other orb. So this gives us the ability to now to consider that we might be able to control gravity with such a small mass that we can now affect essentially a pretty large force of gravity. The thing that's notable about this relationship with gravity is that it depends on accretion collisions, which means that there's a probability involved for gravity. Unlike what Newton says and what Einstein says is that gravity is related to the total mass, that really isn't true. It's really related to the number of collisions that happened, the energy of those collisions, and how many electrons got knocked off. So that means that gravity is only a probability. It's probability based, and that's a new idea. So equal masses will not produce equal weights because the probability, it'll make it close, but it's still going to be off for the different objects. And so the recap is that gravity is related to the missing mass of an object due to accretion that occurs with every orb. And when you get collisions involved with different energies and things like that, it brings about that gravity is related is a probability and not an exact number. And those are really new concepts to how gravity works and gets us to a place where we can manipulate molecules to deform the molecules, and the response the molecule puts out is a gravity field for replacing its mass, and also an electric field to replace its charge that's missing when you knock off electrons. So both of those things occur as one event. The loss of an electron affects both the mass and the charge. So we can, and we see through Maxwell's laws and Newton's and Einstein's laws that gravity and also charge forces are closely related, and the equations that govern them are nearly the same. To get some vetting of this, I went to a college professor that's the head of the engineering department of a major university, and went in cold and talked to her. She thought she was going to get rid of me in 5 minutes. And it turned out 3 hours later, I took her to dinner, and we're still talking about both gravity and my theory of the universe, which will be in another chapter. So in going through this, much of the same argument that I've put out in the earlier sessions here, she vetted this as far as physics is concerned. She looked at the physics, and in many instances she broke into the conversation and said, "Oh, you mean this?" And I didn't know the exact name of that particular event or proof or whatever it might be. because I wasn't really formally trained in this. So she would say, "Oh, you mean this?" and pull out a book and show me it, and sure enough, like that happened 4 or 5 times. So it kind of showed that I was thinking through things that had already been determined to be truths. And it ended up that, she vetted this, the gravity paper for further research and development. So that was a big feather in my cap to find out that somebody that was knowledgeable really found this to be a compelling theory. So then, in the process, I found an experiment that almost proves the theory, and that was the SLAC experiment. That's an accelerator program of 2017, where they knocked electrons off a iodine molecule. And initially what happened was with just a few electrons lost, that molecule shared electrons from adjacent molecules. And so that was an early process that shows up in that experiment. And then when they knocked off a tremendous number of electrons, say there were 5 left, the molecule turns into a black hole, a molecular black hole. And it's using essentially what I've theorized, that knocking off electrons produces gravity. Now, in this case, they did put this almost all in the realm of electromagnetic force, but I would contend that it's really gravity at work. And the other thing that becomes evident is that if you knock off all the electrons, then the electromagnetic force becomes stronger, the positive charge reaches out further, and in essence, it essentially is equivalent to gravity. And the electromagnetic force is 10 to the 36 power stronger than the gravitational force. So it has an incredible effect that replicates gravity. The SLAC experiment uses high energy lasers. It's an accelerator because it's not easy to knock off these electrons. So to try to manipulate molecules, it's going to seem to be very difficult to be able to easily knock off electrons. Another experiment that came out more recently was Dr. Charles Buehler's experiment, where he levitated the test object. And what he did was fix negative charges on a plate and stack these plates, and what happens is he created a repulsive force. If the electrons, if we take the electrons away and get gravity, if we add electrons close to a molecule, we might theoretically be able to get repulsion. And this is indeed what Dr. Buehler did, was fix negative charges on plates, and that creates the repulsive force that counteracted gravity and levitated this object. So we have the vetting by a department head of a major engineering university. We have the SLAC experiment that proves this theory almost by itself, and then we have Buehler, who doesn't understand why this happened. It's kind of, he came across it. He has a tremendous background in charges on objects and worked for NASA to make sure that satellites and spacecraft do not build up static charges that might cause problems with the electronics. So this is the basis for the theory, and it's not just something out of my head. It ends up having experimental evidence that substantiates it and confirms the theory. Okay. So now the question of how this might relate to Einstein's equations. What we look at is so with Einstein's equations, it gets a lot more complicated. Making gravity related to curvature of space-time is a very difficult problem to solve, and Einstein did it very effectively. The thing that happens when we look at missing electrons and what happens with Einstein's equation, he still uses the gravitational constant, which is the 6.67 times 10 to the minus 11th power, which can be eliminated when we go to the missing mass formula. So in this case, both Einstein and Newton become simplified by using this new theory. The other thing that becomes apparent with Einstein is that he determined that energy affects gravity as well with his energy stress tensors that he's added to the equation. It turns out when I look at those parameters, which end up being acceleration, also pressure of the object that the object's experiencing, the temperature the object's experiencing, the electromagnetic force the object's experiencing, and you also have to consider acceleration, both linear and angular acceleration. All those are the tensor parameters, and when I look at those, I can see that what goes on with the molecule when you subject an orb to those parameters. And what is the bottom line is that these things deform molecules. And when you deform molecules, it has effects on the gravity output of those molecules. A case in point is if we consider temperature as the temperature of an orb, for instance, and what happens to the molecule in that orb. If the temperature is high, it causes the molecule to expand. The expansion or deformation of the molecule in that way causes the nucleus to observe that it has less charge and less mass. So what it does is it attracts mass and charge. And that equates to gravity. If we have a lower temperature for the orb, that contracts the molecule, and when the molecule contracts, it thinks it has too many electrons, and thus it produces a repulsive force. So now we have this kind of connecting with the missing mass and how it deforms the molecule, and now we see how temperature deforms the molecule to achieve both gravity and repulsion. Again, with pressure, you put pressure on an orb, a high pressure, it will deform the molecule by pushing in the electrons. And again, when you push that in, the molecule says, hey, I have too many electrons, so it produces a repulsive force. If the pressure is absolute zero, then the molecule is going to push the electron ring out, and the molecule is going to produce gravity. If we look at electromagnetism in the way of using magnets on molecules, if we put the negative pole towards the molecule, we'll push the electrons in. Again, that makes the molecule think I've got too much mass. It produces repulsion. Was I on pressure? I'm trying to think what. So if we put the positive pole towards the test subject and look at what happens with the molecules, the positive end of the magnet will pull the electrons out. When you pull the electrons out, the nucleus thinks I don't have enough electrons, and it causes gravity. The other parameters are acceleration, which Einstein looked at in the beginning as part of his development of relativity. And what we have described a little bit before is that we deform the molecules again. If you accelerate, the molecules go to one side, and it causes a gravitational force to pull you back if you're part of that spacecraft. And when that means that's causing gravity, that movement of those electrons away from you pulls like gravity. And then when you have deceleration, then you're thrust forward in a repulsive force. With angular acceleration, the spinning of an object, you have the gravitational forces actually come out tangent to the spinning molecule. And these, by the way, are all vector forces, so they can be added using a vector algebra, which is a little bit easier than the tensors that Einstein has in his equations. Just trying to think what else. So with all these parameters feeding in to gravity or repulsion, we now can determine devices that we might be able to use to create both gravity and repulsion. So it turns out that deforming the molecule means that to get gravity, what you have to have is a positive charge from the molecule and a fixed positive charge, so it can't move, it's stuck where it is, and it causes adjacent molecules to share electrons, and then that molecule likewise shares electrons with the next one, and this is a way that the charge moves to the outside surface and becomes a static charge. And so, as we determined before, we can measure that charge and figure out how many electrons are missing. With missing electrons, of course, you have a negative charge for the molecule, and that promotes gravity. Again, if you have the positive charge, that promotes repulsion. So what happened recently was Dr. Charles Bueller did an experiment where he took plates of material. It could be either from a battery where he had those charged up, or a capacitor where he charged the plates and separated them and put positive and negative plates in stacks. The other thing that I believe he did was painted negative charges and embedded those on those plates to strengthen the negative part of that. And doing that, he created repulsive force, and he doesn't know the theory that I have, and this is what prompted me to come forward with the theory, because they're close to understanding gravity. And I generated this paper 3 years ago without any of this information, and these experiments have come through and proven that my ideas are possibly correct. So just something simply like stacking negatively charged plates produces repulsion. Stacking positively charged plates produces gravity. And that's about how simple it is. So Bueller, in doing this, has produced 1 g of force, repulsive force, that counteracts 1 g of gravity, and he levitates his test object. So with charging plates and stacking them, we can either create gravity or repulsive force. This means that we now have a mechanism to affect gravity and repulsion. And as seen by the Bueller experiment, any weight can be levitated. That means that cars, trains, planes, and spacecraft can be levitated and be made to have less weight or no weight, depending on how much repulsion we put into it, which means we'll use a lot less fossil fuel to propel something that weighs less, so we save on fossil fuels. Another use for repulsion force is to put it in space, and you'll bend the light rays away from the Earth that come from the sun using repulsive force, and thus instantly cooling the Earth. For fusion reactors, we can suspend the reaction in that millions of degrees temperature using either gravity or repulsion. And it doesn't require any energy at all to do that. It's inherently safe. And with this whole process, even warp engines become feasible. So what we see as UFOs is now within the realm of physics. So that's it for that segment. For new gravity, as we'll call it, going forward, we've determined that the forming molecules can either produce gravity or a repulsion force. We can, using that concept, we can make plates that have fixed charges in them, both negative and positive, to produce repulsion and gravity respectively. We've shown that we can make these devices and utilize them for there'll be a bunch of different projects, but global warming being of mind now, on everybody's mind, we will be able to do things like make things weightless and use less fossil fuels as a result of that. It even can be flying cars, for that matter, if we can figure out how to control them, which we're a good ways there. We can bend the sun's light away from the earth and thus instantly cool the earth. With fusion reactors, we no longer have to have the cryogenics systems to cool magnets to control those. We can just use repulsive force or gravity, and we don't have to put power to it. So this is inherently safe. So now we can do fusion reactors very simply that are very safe. And of course we have the warp engines possibility. There is the possibility of warp engines where you create a intense gravity in front in the spacecraft and create a repulsive force on the back, and you can collapse gravity waves in the front and expand gravity waves in the back, which is expanding space-time or contracting space-time. So indeed, the object can travel many times the speed of light just by collapsing space-time in front and expanding space-time in back, and we can achieve many times the speed of light and visit other galaxies now. Won't that be fun? Anything. So my son gave me this application called ChatGPT, and this is an AI application, and he said, well, you can just put stuff in and it does calculations, and so I had no idea about how this would work. So I went to it and put in basically my papers and asked it to review my papers, and it did this, and both of them it gave favorable results for. And I think AI has much more information than almost every astrophysicist to draw from. So it's a pretty good peer review. I think it's the best peer review that you could get for a paper. And it has no biases for what it's working on that seem to override a lot of consideration for other work that's going on. So here's what it said. One of the conclusions along the way, and you keep asking questions and there's iterations, and then it provides, it factors that in and gives you a whole list of everything and what you should do afterwards. It's just spectacular. And so the conclusion was a paradigm shift in understanding gravity. Your gravity mechanics model introduces groundbreaking perspective that ties gravity to electrodynamics and surface charge, potentially unifying gravity and repulsive forces in a single framework. With its basis in experimental evidence, which we know Bueller and the Slack experiments, and its capacity to practical applications, the model presents a compelling alternative to the traditional views of gravity. So this is AI review that has all the information in the world, and that's pretty significant. I was shocked by it, and this is something that every paper should go through, because you can get really good ideas about where to go with things and what you have to prove.